Alrighty, so we are going to go over absolute value functions and the transformations of them. All right, our objectives is to graph an absolute value function by performing transformations on the parent function. And then we're going to apply transformations to graphing any function, which will be in another PowerPoint this week. Building the absolute value function. The absolute value function is defined by f of x equals the absolute value of x. And the graph of the absolute value function is similar to the linear parent function, except it must always be positive. So we're just going to take the negative portion of the graph and reflect it across the x-axis, making that part positive. So the absolute value function is defined by f of x equals to the absolute value of x. And this is the parent function. This is what the parent function looks like. And it is a v with a slope that is 1 to 1. To the left of x equals 0, the graph is given by y equals negative x. Then you have the vertex here at 0, comma 0. And to the right of x equals 0, the graph is given by the line y equals x. Yes, it is V-shaped. It is symmetric around the y-axis, and the vertex is the minimum point on the graph. A translation is a transformation that shifts a graph horizontally or vertically, but does not change the overall shape or orientation. Please notice that we have moved this from the origin over h and up k. Okay, so the translation h is for horizontal units and k are vertical units. And so then the new vertex is at hk. So in this case, notice that the vertex has moved from 0, 0 to 1, 4. Thus, the h is equal to 1 and the k is equal to negative 4, which you can see from the equation up here, the 2 times the absolute value of x minus 1 minus 4. So please notice that this minus 1 that's in here actually moves to the right. So the big thing about h is it's always opposite of what you think it is. So if you have a minus 1, that means you've gone to the right. If it had been a plus 1, we would have went to the left. The slope of this one has changed as well because you have a 2 now in front of the absolute value sign. Okay, so the stretching and shrinking or stretching and compression of a graph of y equals ax is that the a acts like the slope. Okay, and in fact, it is the slope because we are talking about straight lines for absolute value. So if you have where a is greater than 1, then your shape is narrower. In other words, the graph is vertically stretched or elongated. If, however, you're talking about a less than 1, where you're talking a fraction, then that is vertically shrunk or the graph becomes wider. Okay. Another thing that A can do is reflect the graph across the x-axis. So when A is less than 0, then it just reflects across the x-axis. Okay, so just flips it. Now we can do multiple transformations at once, okay? And we can do translation, reflections, stretches, or shrink. And to graph an absolute value function, start by identifying the vertex. Well, identifying the vertex is always easy because the h is with the x and the k is always hanging out by itself. Note, if positive h inside, that means the h is negative, and if negative h inside means the h is positive. So again, you're taking out the opposite of the number for h. You use the a value as a slope to plot more points. Remember that you have to do positive and negative slope to get points on both sides of the V, and then you just connect the dots in a V shape. So if we look here, we're going to graph the following function without making a table. And the neat thing is that here is the parent function going through the origin, okay? And the graph will go right to and up 3. So we know that the vertex is 2, 3. Now from that point, use the positive and negative slope, and our slope is just equal to 1 to get more points. So there is your vertex at 2, 3. We're going to go over 1 and up 1 on both sides in order to be able to sketch in the line. That's all you have to do. In this case, we're actually not translating it right or left, but we have a 1/2. So we still have a vertex at 0, 0. And now we know that the slope is 1/2. So we're going to go up 1 and right 2. And then we'll go up 1 and left 2. And so you can see why they call this a shrink, is because it opens up, it becomes wider, it shrinks down the y-axis. Okay, we're going to graph the following functions. And again, we don't make a table. We can see that the vertex is going to be -1, -2. So we go over to -1 down to -2, and there's our vertex. Notice that it says that -3 is our slope. So we're going to go over 1 and down 3, both to the left and to the right, in order to pick up our next points, in order to be able to graph. Okay, so you can perform transformations on a graph of any function in a manner similar to this, and we will be doing these in another PowerPoint. Thank you very much.